Hello everybody and welcome to lesson 9.1 Equations of Circles. Today we're going to learn about where the equation of a circle comes from and how to both write the equation of a circle and graph a circle. So a circle is simply the set of all points in a plane that are a fixed distance, the radius, from a point called the center. So when I look at this circle here, you can see I've got a radius here, that is a fixed distance away from the center, and all my points circle around the same distance. Now, what's really cool is that our equation of circle is actually based on the Pythagorean theorem. Because what ends up happening, if I were to draw a line straight down and straight across for my x and y values anywhere on a circle, I create a triangle where my height is y, and my base length here is x, and of course the hypotenuse would be r squared. So any point on a circle relates to the radius according to the Pythagorean theorem. X squared plus y squared equals r squared, which is really quite cool. But of course, we don't always have our circle centered at 0, 0. Sometimes we move it around. So now, if I were to move my circle around, well, my length now here, x, is the same thing as x minus the h value that I've shifted my center. And my length y now is y minus the k value that I've shifted my center. So the equation of my circle now is x minus h squared plus y minus k squared equals r squared, where I have a center at h comma k and a radius r. If you remember one thing today, this is the most important thing right here. So, looking forward, let's talk about how we actually write the equation of the circle. The first thing you're always going to do is identify the center and the radius. So looking at this circle here, I'm going to go through and I'm going to draw diameters, and I'm going to see where my diameters meet. So if I draw a diameter straight down and I draw a diameter straight across, I can see that they're meeting right here at 0, -3. That must be a center. Another way to do this would be to look at the diameter and to find the midpoint of that diameter. So this diameter goes from 0, 2 to 0, -8. And if I want the midpoint of that, I would do 0 plus 0 over 2, 2 plus -8 over 2 to produce my center of 0, -3. So once I do that, I'm going to replace my h and k values inside my equation with the values for my center. So again, our formula is x minus h squared plus y minus k squared equals r squared. So now when I replace h and k, here I would get x minus 0 squared plus y minus -3 squared. And then last but not least, I'm going to replace r with the radius, replace r, I would say, with the length of the radius. So when I'm looking now at my radius is how far I am from the center to the edge of my circle. So here I am 1, 2, 3, 4, 5 units away to the edge. So my radius is 5 squared. And then I'm simply going to simplify. X minus 0 is just x squared. Y minus -3 is just plus 3 squared. And 5 squared is 25. And so that would be the equation of that circle. Let's do some examples. We're going to write the equation of a circle centered at negative 9, 6 with a radius of 8 units. So I'm going to always use my standard format, x minus h squared plus y minus k squared equals r squared. And I'm just going to plug straight in. X minus the x value of my center is negative 9 squared plus y minus the y value of my center is 6 squared equals a radius. My radius is 8 squared. So this becomes x plus 9 squared plus y minus 6 squared is equal to 64. So I want you guys now to try this question here. Try me. And I'm going to check and see if you did it next class. All right, now let's take a look at a slightly harder problem. I now want to write the equation of the circle who has a diameter with those endpoints. The center will always be the midpoint of my diameter. So the first thing I'm going to do is I'm going to find the midpoint of between these 2 points. So if you guys remember from a long time ago, we find our midpoint with the average of my x values and the average of my y values to get the midpoint. Well, my x values are 1 and 7, and my y values are negative 8 and negative 2. So I end up getting 8 over 2 is 4, negative 10 over 2 is negative 5. So 4, negative 5, that's my h comma k, that's my center. Now my radius, we can do 2 ways. I can either find the distance between these 2 points here and then half it to get the radius, because that's a diameter, or I can pick my center point and do the distance between my center point and one of my endpoints, which is what I think I'm going to do. So to get my radius, I'm going to use distance formula, which is the square root of, if you guys remember, difference in x's squared plus difference of y's squared. So plugging into that, square root of, I'm going to do 1 minus 4, because I'm doing this point and this point, 1 minus 4 squared plus negative 8 minus negative 5 squared, which gets me the square root of 1 minus 4 is negative 3 squared plus negative 8 minus a negative 5 is also negative 3 squared, which gets me the square root of 9 plus 9, where r equals the square root of 18, or that's 9 times 2, so 3 root 2. All right. At this point, I can plug into my formula. So we do x minus the x value of the center is 4 squared plus y minus the y value of my center is negative 5, so I'm going to make that a plus 5 squared equals r squared, 3 root 2 squared. And that would be my answer. So now the radius is the distance between the oh, I should have done that. Sorry, guys. We could have done all of this work down here. That's where it was supposed to go, but y'all are smart kiddos. You'll figure it out. So let's look at the next page. All right, let's graph some of these guys. So the key to graphing this is first to always identify the center and your radius. So remember my center, if we have x minus h squared plus y minus k squared equals r squared, then my center is at h comma k. I have to flip the signs. So here my center would be at 2 comma negative 3, and my radius is always r. So what I have to do, if 16 equals r squared, then 4 must be my radius. So my radius here is 4. So what I'm going to do now, I'm going to plot my center at 2, negative 3, just like that. And then I'm going to make 4 points that go up, down, left, and right that are all a distance of 4 away from that center. So I'm going to go up 4, right 4, down 4, and left 4. And then I am going to connect as best I can, because this is hard to do. I'm going to connect those points to make a circular shape. Now, I believe I might have the capacity to actually do a proper circle, which I know y'all can't do, but anyway, something like that. We get the idea. Okay? So, I want you guys now to do this one. Chiming. Okay, I'm going to be checking it next class. And then let's take a look down here. So here I've got x plus 1, and then there's y plus nothing. So that means my center is at -1 for the x, but when I don't have a plus anything, then my y value is just at 0, because I don't have to include plus 0, minus 0, so on and so forth. And my radius here is 5. So I'm going to plot my point at -1, 0, and then I'm going to go 5 out in 4 directions. 1, 2, 3, 4, 5. Drop a point. 1, 2, 3, 4, 5. Drop a point. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And then we just connect to make a circle as best we can. Okay. And last but not least, this one is kind of interesting. So here, my center here is at x is 0, y is 1. But the hard part here is the radius. Because I've got that r squared is equal to 37, which means that r is just a little bit bigger than 6. Now there are 2 ways to go about doing this problem. The first way is regular math way, which would be to simply go through, plot your point at 0, 1, and then go just a little bit higher than 6 for each of your 4 points. So go up 6 and up 1, 2, 3, 4, 5, 6, and just above it and put a point. That's a good estimation. But there's actually an accurate way to graph this problem. Because if I think about it, 37 is the same thing as 36 plus 1. So when I was doing the Pythagorean theorem to find that length, that means at some point I had r squared equals 6 squared plus 1 squared. So that means that if I can go up 6 over 1 or over 6 up 1, that will still create a segment length that is square root of 37 long. So I'm going to take a look at that. If I go over 1, up 6, the distance from here to here is still square root 37. I'm just no longer going straight up or straight across because I can't with the square root of 37. So same thing could happen if I go over 6 and up 1. Or for that matter, over 6 and down 1. Or we could go over 1 and up 6. So I can actually plot not 4 points, but 8 points with this method. I can go over 6, 4, 5, 6, up 1, and over 6, down 1. And then down 6, 2, 3, 4, 5, 6, over 1, and down 6, over 1. So when I do that, all of these radii that I could draw into these points, they're all going to create little triangles whose hypotenuse would be 37, or square root of 37. So now we just join them together as best we can, because again, we know it's not going to be perfect, because drawing circles is hard, unless, guys, if you have your compass, in which case, knock yourselves out and use your compass. Did I do that one wrong? That should have gone to right there. I did that one wrong. Sorry, guys. And then connect. And so that's how you would graph. That's how you would graph a circle.